Hi everyone, Mrs. Musaf here, just doing another example with these limits just to talk about how they kind of look with piecewise functions and to review graphing piecewise functions if necessary. Alright, so here we're given a piecewise function, right? F of x equals 3 minus x when x is less than 2. It equals 2 when x is equal to 2. And it equals x over 2, or 1/2 x, however you prefer to look at it, when x is greater than 2. Alright, so first things first with piecewise functions, a lot of times it's helpful to graph it. Now, if it asks you to graph, obviously we want a pretty precise graph. If it doesn't, then drawing a rough sketch is fine too, just so you know what's happening at those critical points. For example, in this case, we want to know what's happening at x equals 2, so we know whether this graph is connected or disjointed. Okay. So when I go ahead and graph this, I'm going to do a pretty, relatively precise graph. No rulers or anything like that, but get a couple points. Notice how all of these are linear pieces, which means you really only need 2 points in order to draw the graph. All right, so something to think about. So for this first piece, f of x equals 3 minus x when x is less than 2. Well, first things first is I need to know what's happening when x equals 2. Even though x equals 2 isn't part of this piece, right? It just means it's going to be an open circle, but the graph still starts, at that value, because what about at 1.9 or 1.99, right? We still need those points. So I still need the point where x is equal to 2. I'm just going to make it an open circle. All right, and if I want to find that point, I'm just going to plug it in. If I plug in 2, 3 minus 2 is 1. So that means I'm going to have a point at 2, 1. It's just going to be an open circle. Right? Then to draw the rest of this piece, I need to make sure I'm only using x values that are less than 2. So I could pick an x value that's less than 2 and just plug it in. Or I could use the fact that this is a linear function, right, like y equals mx plus b, and the slope is -1. So to get another point, I'm just going to use my slope. I just have to make sure that other point is to the left, so that x is less than 2. So if I use a slope of -1 to go to the left, that means I'm going to go up 1 and left 1. Right? That's a slope of -1. And then I can draw my line from there. Okay. This middle piece, it says f of x equals 2 when x is equal to 2. That's really just giving you a point, right? The point 2, 2. So it's defining what y is at x equals 2. And so I'm just going to plot that point, 2, 2, right there. Okay, and then for my last piece, this is for when x is greater than 2. So again, I still need to know what the point is at x equals 2, and it's just going to be an open circle. If I plug 2 in for x, 2 divided by 2 is 1. So I would have 2, 1. Oh, look at that, same open circle. But then to finish drawing this piece, my slope would be 1/2. Make sure it goes to the right. Right, so if I go up 1 over 2, it would be this line right here. All right, or you could pick an x value to the right of 2 and plug it in. It's your call. All right, so this is my graph of the piecewise function. Now that I can see the graph, it's a little easier to answer the next few questions. Part B, it says, find the limit as x approaches 2 from the left of f of x. Find the limit as x approaches 2 from the right of f of x, and then find f of 2. All right, so let's start with the limits. The limit, just going to rewrite it. It's good to practice rewriting this just so you get in the hang of how to write it. All right, the limit as x approaches 2 from the left of f of x. If I take a look at my graph, from the left would be this piece right here, and it's approaching this y value, which would equal 1. All right, same kind of thing for the second limit, the limit as x approaches 2 from the right of f of x. All right, from the right means it's going to be from this other piece. But again, as I approach x equals 2, the y value it's getting closer to is also 1. So that limit's going to equal 1. For this last piece, f of 2, that's saying what is the function actually defined at when x equals 2. So now I'm not looking for a limit. I'm saying, all right, when x equals 2, where's the point? And be careful, an open circle does not count as a point. All right, it has to be a closed circle, which would be this one right here. And that y value would be 2. So f of 2 is going to equal 2. Okay. Part C says, does the limit as x approaches 2 of f of x exist? And explain your answer. Remember, in order for an overall limit to exist, in other words, a two-sided limit, both one-sided limits have to equal the same thing. And here I can see that as x approaches 2 from the left and as x approaches 2 from the right, both of those limits equal 1. So because of that, I can say yes. The limit as x approaches 2 overall of f of x exists. And the best explanation would be exactly what I said, the fact that the limit from the left side is equal to the limit from the right side. All right, so yes, the limit as x approaches 2 of f of x exists because the limit as x approaches 2 from the left equals the limit as x approaches 2 from the right of f of x. Okay. Some people think that the fact that f of 2 equals something different would make a difference with this limit existing, but it doesn't. Remember, limits are just what it's approaching. We don't actually care about what's happening at the value. Eventually, we're going to talk about what it means to be continuous, and then this piece will come into play. But for now, when we're just talking about limits, we don't actually care what's happening at the x value. We just care what's happening as you approach it. Okay? So that's how piecewise functions work. If you have questions on piecewise, just make sure you write them down, and maybe your teacher can help answer them, or feel free to YouTube some piecewise function videos, right? Graphing piecewise functions, and maybe that will help answer any questions you've got. All right, that's all for this one. Thanks for tuning in.